Okay, welcome back. We are continuing on with our notes for day 1 of pre-cal, and this is section 2.1 in your note packet. Okay, so a relation is the correspondence between two sets of data. So if we let x and y be two non-empty sets, a function from x into y is a relation that associates with each of the element of x with exactly one element of y. And remember, this is our definition of function. A single x cannot have two different y's. We also do the vertical line test to test for that. But the set of all possible x's is what we call the domain. The set of all y's we call the range. So we want to see if each of these represents a function down below. So we've got to make sure our x's do not repeat. So x, 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 they do not repeat. So yes, that is a function. And then we have to state the domain and range. So when we've got a list of points, the way we list our domain is as the set. So we've got the domain is the set of 1, 2, 3, and 6. All the x values. Our range is the set of all the y's. So 4, 5, 6, and 7. So everything is listed. If something were to occur twice, we only list the unique elements. So let's take a look at this next one. Again, a set of points. They are a relation, and we're trying to see if that is a function or not. Okay, do any of the x's repeat? 1, 2, 3, 6. They don't repeat, so this is a function. And then my domain is the set of all the x's. 1, 2, 3, and 6. And we generally try and put them in order from smallest to largest, even if they don't occur that way in our relation. Our range is the set of y values. So we've got 4, 4, 5, and 10. I don't list 4 twice, so I just have 4, 5, and 10. And it is perfectly okay if your y's repeat themselves. That doesn't affect whether or not it's a function. Okay, our last one. Again, we want to see, do our x's repeat? -3, -2, 0, 1, -3. Okay, so this is not a function. And our domain is a set of -3, -2, 0, and 1. I don't list the -3 again. And my range is the set of the y values. So we've got 9, 4, 0, 1, and 8. I'm going to start with the smallest one, so 0, 1, 4, 8, and 9. And feel free if you want to cross them off as you list them to make sure you don't forget any of them. Perfectly okay. Okay, so let's see down here. Determine whether the equations when y is defined as a function of x is a function. So let's see. We've got y by itself already, so that's great. Hopefully we recognize this is just the form of a line. Straight line, slope of -1/2, y-intercept of -3. A straight line is a function, so yes. Let's take a look at this other one. We need to get y by itself. So the first thing I'm going to do is subtract 1 from both sides. So I have x minus 1 equals y squared. And of course, to get y by itself, I've got to take the square root. And hopefully we remember when you take the square root, there's two possible values, a positive and a negative. So we get y equals positive square root of x minus 1, or y equals negative square root of x minus 1. Well, since for any x I put in here, I can have two different y's. This is not a function. And again, from Algebra 2, hopefully we remember, this is our square root function. Okay, example 3. We are going to be doing the same thing. Actually, we're not doing the same thing here. We've defined our function f to be -3x squared plus 2x. So for any value of x, if I want to evaluate f of some number, I'm going to put that number in wherever there's an x. So let's see here. F of 3. That means I want to evaluate the function when I put 3 in for the x's. So when we do that, the function is -3 x squared. So my x in this case is going to be 3 squared plus 2 times whatever I'm putting into the function, which is a 3. So here I've got to do the exponent first. So 3 squared is 9 times negative 3 is negative 27 plus 2 times 3 is 6. Negative 27 plus 6 is negative 21. So that is the value of f of 3. We can just put that here. F of 3 equals negative 21. Okay, so this one, we're adding a function. First time, we're going to put x into the function. The second time, we're putting 3 in there. Now, f of x, we know what that is. It's negative 3x squared plus 2x. So I'm going to just put negative 3x squared plus 2x plus f of 3. Well, f of 3 we just defined was negative 21. So plus a negative 21. There's nothing to distribute, so this is defined as negative 3x squared plus 2x minus 21. And that's what that equals. This time, we're taking our function and multiplying it by 3. So that means everything that makes up my function is going to get multiplied by 3. So I would write that as 3 times my whole function, negative 3x squared plus 2x. And of course, I've got to distribute this 3 to both terms that are inside the parentheses. So I would have negative 9x squared plus 6x. And again, that is what 3f of x is equal to. Now this time, we're going to take, instead of putting x in my function, I'm going to put a negative x in. So everywhere there's an x in here, I'm putting a negative x. So this will be negative 3 times, be very careful with our negatives here, negative x squared plus 2 times a negative x. Okay, let's evaluate this. And again, we're going to do the parentheses with the exponent before we multiply by the negative 3. So negative x times negative x gives me a positive x squared. So now I have x squared times a negative 3. And 2 times a negative x is a negative, let's negative 2x there. And again, distribute here, we've got negative 3x squared minus 2x. So f of negative x is equal to negative 3x squared minus 2x. And now we're going to play around with putting that negative sign out in front of the equation instead of putting it with the x. Okay, so this just means I'm putting a negative out in front and then writing my whole function. So that's negative 3x squared plus 2x. Distribute that negative to both terms. Negative times a negative gives me a positive 3x squared. Negative times a positive gives me the negative. So there is my function is 3x squared minus 2x. Okay, got 2 more on this page. So now we have f of 3 of x. So this means anywhere there was an x in my original function, where are we? Right there. I'm going to substitute in 3x. So this is going to equal, my function is negative 3 times my input. My input is 3x. I need to square that. Plus 2 times my input, which is 3x. Because this, in the parentheses, is just saying this is my input in the function. And again, let's evaluate this. So we've got a negative 3, and then we've got a 3x squared. We do this exponent first. So 3x squared is 3x times 3x, so that's 9x squared. And notice the squared is now with the x instead of on outside of the parentheses. Plus 6x. Multiply this by negative 3, and we get negative 27x squared plus 6x. Okay, one last one right here. This one we're plugging in x plus 3 into the function. So we're going to have negative 3 times x plus 3, that's your input, and we are squaring that, plus 2 times our input. And the input is x plus 3. So we've got to go ahead and evaluate these. X plus 3 squared gives me x squared plus 6x plus 9. And here I'm going to go ahead and distribute the 2. So I have 2x plus 6. Distribute the negative 3 here. We've got negative 3x squared minus 18x minus 27 plus 2x plus